So good afternoon everybody, myself Acharya Vishvendra, and today I'm going to discuss nuclei in a nutshell. So let's start with that. So we have the concept of nuclei, and the historical experiment was done by Chadwick, uh, and it was based on alpha particle scattering experiment which proved the existence of nuclei. So nuclei is represented by ZXA. Z is called the atomic number or number of protons. A is called the mass number or number of protons and neutrons. Then there is a question based on the radius of the nuclei. So radius of nuclei is R naught, A raised to power 1 by 3, where R naught is 1.2 FM. FM means 10 raised to power minus 15 meter or 10 raised to power minus 13 centimeter. Then radius of nucleus having mass number n, this is proportional to n raised to power 1 by 3. So R1 by R2 is R2 by R1 is N2 by N1 raised to power 1 by 3. If we take the ratio of surface area, it's gonna be square of the radius, so power 2 by 3. For volume, it's going to be A2 by A1. One important concept is nuclear density is constant for all nuclei, and it has an order of 17, which is comparable to that of neutron star. So we can say that nucleus is very densely populated. Now there is an alpha particle scattering experiment in which we had the source as 83 it's Bi 214 and iodine 214, and we used alpha particles which had a kinetic energy of 5.5 mega electron volt. They were made to pass through lead bricks so as to form a collimated beam, and then made to strike thin gold foil having thickness of 2.1 into 10 to the power minus 7 meter, and there was a zinc sulfide screen. This was the interpreter detector, and it detected electrons scattered at a certain angle theta. Then we draw graph between n and theta, and it was found by experimental analysis that Na is proportional to 1 upon sine 4 theta by 2. So for two different angles we have the relation that n1 by n2 is sine 4 theta 2 by 2 upon theta 1 by 2. For a special case when theta is less than 5 degree, so we can approximate sine theta by theta into pi by 180. So from there we can conclude that n1 by n2 is theta 2 by theta 1 raised to power 4. One important concern case is n is maximum when theta is 0 and n is minimum when theta is equal to 180 degree. Let's analyze the results of this particular experiment. So the results are that most of the alpha particles went straight without deflected. Next, about 0.14% got deflected by more than 1 degree. Next, only 1 out of 8,000 got deflected by more than 90 degree. Next is a concept of impact parameter, which is the initial perpendicular distance of velocity vector from the center line of the nucleus. And we can say that larger the impact parameter, the lesser is the deviation, and it is maximum then deviation is minimum, and when it is minimum the deviation is maximum. Obviously nearer it will be to the nucleus, more will be the electrostatic force and more will be the deviation reduced. So next one, now we have three different cases. There are three particles moving having impact parameters B1, B2, B3. As you can see over here that B1 is minimum and B3 is maximum, so inverse will be the scattering. So we can say that larger the impact parameter, smaller is the scattering and smaller is the deviation. So this we can conclude from these experiments. Then there is a concept of nucleides. They are categorized as isotopes, isobars, isotones. Isotope means same atomic number but different mass number. Example 1h1, 1h2, 1h3. Isobar, same mass number but different atomic number. Example 1h3, 2he3. Isotones having same number of neutrons. Example 80 Hg 193 and 73 Au 197. You can calculate. Then is the concept of AME, atomic mass unit, which is 1/12 the mass of carbon 16 atom, which is equal to 1.66053 into 10 to the power minus 27 kg, and the mass of hydrogen is going to be this. Then we have average atomic mass, which is M1 plus N2 by 100, where M1 is N1% abundant and M2 is N2% abundant. For example, chlorine has two isotopes having atomic numbers 34.98 and mass numbers 34.98 and 36.982. Their relative abundances are this. So if we calculate using this formula, the average atomic mass comes out to be average atom mass number comes out to be 35.46 U. There are certain important points that Chadwick was given Nobel Prize for discovery of neutrons. Then there is a concept of free neutron is unstable and decays to proton. Then mass energy equivalence, it was given by Albert Einstein, which says that E is equal to mc square. So if we draw a graph between energy and mass, the graph will be a straight line. Tan theta will be E by m, which is equal to c square. So this is the concerned thing about the nucleus. Let me to repeat things once. So this chapter is about nucleus, which was proved by alpha particle experiments, represented by ZXA, radius of nucleus proportional to a raised to power 1 by 3, surface area proportional to power 2 by 3, volume proportional to A2 by A1, density 1. Nuclear density is very high, comparable to neutron star, having order 10 raised to power 17 kg per meter cube. Then we have alpha particle scattering experiment, in which we had the empirical formula that in proportion to 1 by sine 4 theta by 2. And there is a comparison of that larger the angle, lesser will be the scattered particles. Then we have some statistical fact about this experiment. Then we have the concept of impact parameter, and we came to know that larger the impact parameter, lesser will be the deviation, and vice versa. Then we study nucleides, which are isotopes, isobars, isotones. Isotopes have same atomic number, different mass number. Isobars have same mass number, different atomic numbers. And isotones have same number of neutrons. Then we studies about AMU, its number, average atomic mass of chlorine. Then we studied about the concept of a free neutron, which decays to proton when left free by itself spontaneously. Then we had energy mass relation, which was given by Sir Albert Einstein, according to which any piece of mass corresponds to energy, which is called energy mass equivalence. And because of this, law of conservation of energy or mass is replaced by the concept of law of conservation of mass and energy. So if you draw graph between E and M, the graph is going to be a straight line. Let it makes an angle theta with the m axis. Then we have tan theta is equal to E by m, which after solving gets out to be c square, which is very large. So this angle will approximately be 90 degree, as you might be knowing that 1090 tends to infinity. So this was regarding a brief snapshot of nuclei, part 1 we have done. So it's all about the concept of nucleus, its radius, surface area, volume, density, scattering experiment, impact parameter, nucleides, isotopes, isotones, isobars, AMU, atomic mass average, and at the last but not the least, the energy mass equivalence, which is the basis of nuclear energy. When positively used, it can lead to nuclear reactors. Negatively used, it lead to atomic bomb of Hiroshima and Nagasaki, has been as an historical example in World War II. So these were certain things regarding nuclei. I hope it works for you. Thank you. Have a nice day.